Hello, everyone, and thank you for joining us today for our HashiCorp webinar, where today we'll be addressing secrets management in a highly regulated environment. My name is Connor Beechnor, and I'll be your moderator for this session. And today I'm joined by a selection of speakers. Firstly, we have Pedro Coca, who's our Regional Manager for Solutions Engineering here at HashiCorp, and he's joined by Marc Cluet, who's a Channel Solutions Engineer here as well. Today, we also have the pleasure of welcoming a very special guest, David Duke, who spent many years working in the financial services industry for a well-known challenger bank. In terms of the agenda, we'll start off with an overview of HashiCorp and then look at some specific challenges like open banking and how they're affecting the financial services industry right now, and ultimately how HashiCorp Vault can help address some of these. We'll then have a live Q&A with David and hear about some of his experience in this area. And we'll then have a live Q&A with the wider audience. With that in mind, if you do have any questions throughout the presentation, please post them in the Q&A box provided at the bottom of your screen, and we'll answer those at the end. Please note this webinar is being recorded, and we'll share that with everyone via email after it's been processed. Usually that takes a day or two. So with that, over to you, Pedro.
Thanks a million, Connor. All right, so let's start with a brief introduction of HashiCorp, and I'm gonna stop the video to get full attention to the slides. So we are a leading cloud infrastructure automation company, and we have a set of tools for addressing in order to address different challenges in that space. So in the right side of the screen, you can see the list of tools, and you can see Vagrant, Paca, Terraform, Waypoint, Vault and Boundary for security, Consul for networking, and Nomad, that is our scheduler. And those are open source tools. And we have enterprise versions for a subset of them. So we have enterprise versions for Terraform, Vault, Consul, and Nomad. So we are trying to support those applications and the infrastructure that is underpinning them, supporting them. So the company itself was founded in 2012, 9 years ago. We are a fast-growing company. We are already 1,300 plus employees, and we are well-funded. Last year, we got the last round of finance, and we got like 350 million overall in funding. So in terms of enterprise customers, we have more than 1,000 enterprise customers. 7 out of 10 of the Fortune 10 list are companies that are in our customer base. And most importantly, 80% of the top global financial companies are our customers as well. So we have a lot of experience with enterprise companies, and we have seen those companies facing a common set of challenges, moving to the cloud and getting a huge transformation that is right now undergoing. So we often see those companies tackle the huge change, the huge move that happens maybe once or twice in a lifetime, every 20 years or so. And right now we are seeing many challenges moving to this more dynamic, modern data center environment where you have different cloud providers in the mix. So the big question is, how can we accelerate and can we put a value in front of our customers and clients? And it's something that Marc and I are going to talk in the next few minutes. So we are coming from a world with dedicated infrastructure, dedicated computing, where if you needed some kind of resource, you need to request the access to that resource, often with an IT ticketing base. So the IT departments were basically guardians of the IT instead of enabling these solutions. So right now we face a reality with multiple clouds, either by design or if you will face your company being a multi-cloud company in the future, maybe with acquisitions in the mix or any other element that will become multi-cloud a reality in your company. And then we have to face the spiky nature of the workloads nowadays. So the new systems of engagements, the mobiles and the tablets need to interact with those systems of record, the databases that are in the traditional data centers, and those interactions are creating some pressure, some friction in different elements. So we're going to decompose that transformation in different tiers, and we're gonna pay some attention to the different levels, to the different tiers in this modern transformation. So we have implications in the provisioning layer. So we are moving from dedicated servers, dedicated compute, to basically resources on demand and in a wide variety of environments. We are going to have implications in the security layer. So we are moving from the locality of an IP address as the source of trust, where you have that IP address that is highly trusted and will access pretty much all the resources in the data center, to something that is a low trust model, where you need identity as the base of your security, where IP addresses are ephemeral, are no longer something that lasts for years or even more, but is very ephemeral. And that has a huge impact on the way you operate your infrastructure, your applications, and your security. And we're gonna see a few of those implications. And also that change has an impact in the networking layer. So the way you connect your applications is way different. Now you need the right set of scale, the right set of abstractions, and the right set of tools to manage services, not just applications with an static IP address. And the same happens in the execution, in the running tier. We were familiar with that environment that we can touch, we can name the servers that would run in the applications with that dedicated compute. And now we are moving to microservices, and those workloads need to be scheduled across the fleet in different cloud providers and also on-prem. And if we zoom in this matrix, we're going to see different technologies for every tier. So if you are in a provisioning environment, maybe you're familiar with CloudFormation, maybe you are using ARM templates. If you are working with Azure, the same implications happens in the security tier. So you're going to have different identity sources, different ways to manage your identity. If you are talking about an on-prem environment with typical Active Directory or LDAP directory, or maybe any cloud identity and access manager. The same will happen in the networking layer with different solutions, and obviously the same happens when you are running your applications. This matrix gets more and more complex, so it's really different to tackle, really difficult to tackle those problems if you start doing what some companies have been doing, that is basically creating teams for every single cell, potentially creating silos, duplication, and in practical terms, you are diminishing the velocity of developers and the whole company, the whole organization. So one of the things that we have seen as a success, and one of the things that we advocate, is having a common control plane in those different tiers. So the cloud operating model advocates for that common workflow, that common control plane across technologies, because it's basically about workflows and not particular technologies in these tiers. And we have a tool for each layer. So we have Terraform in order to provision in infrastructure. We have Vault, and we're gonna talk extensively about Vault today. And we have Consul for the networking layer, and also Nomad for running the applications. And in common with all of them, we have something that is called Sentinel, that is the policy as code framework. And we are going to talk about policy also in this session. So this is the model that we advocate, a cloud operating model, where you are going to have a common control framework in infrastructure, security, networking, and runtime. And you can deliver application workloads to multi-cloud environments. And in that way, you're going to have that velocity to put applications in front of customers and clients in a really short time. So that's what we advocate, and now we're gonna see a few challenges in the industry, and for that Marc is gonna talk about some of these challenges, the landscape, the position in the industry. So Marc, over to you.
Cool. Thank you very much, Pedro. So if you can pass to the next slide. So I've worked in the banking industry in a couple of countries, and also I've been working with insurance industry, and this is the biggest challenge that all of them are facing for the last 2 years. There's a lot of new competitors in the market that are FCA regulated, that have all the guarantees, and even some of them have banking licenses and license to issue insurances as well. And these companies, they work in a very agile fashion. They don't have any kind of legacy systems as well. So they can create something from zero that is modular, that is modern, and is structured as microservices as well. And normally their time from ideation to market, which is the time from when the idea is first thought to actually being able to expose this to customers, is around 4 to 6 months. And this for banking is a very short time to go to market, especially considering all the challenges and all the different policies and governance that they need to follow. So if you can pass to the next slide. So the big problem that we have then is that we have an infrastructure that is not allowing us to go to market as fast as we should, or as fast as these new fintech companies go. On top of that, we have servers that are not fit for purpose. And by not fit for purpose, I don't mean that data centers become obsolete, but there's a lot of pull to go to the cloud in order to be able to reduce the capital expenditure. So that means that the capital expenditure, which is what you invest in buying servers, buying data centers, and buying all that infrastructure, is now more seen as a risk asset rather than an investment into the future of the business, because you can easily create these machines in the cloud, and you can easily transform this capex to opex, and be more interesting to your I would say to your shareholders. You also need to go through your risk and governance processes. These processes have been created a long time ago, and they are very laborious and very heavy, in the sense that normally whenever we wanted to release a new piece of software, just by the risk and governance process itself would take at least 4 months, and that would be not even thinking about creating the code itself or anything else. And on top of that, there's new regulations that we'll see a bit later, and that pushes banks to start talking more through APIs, which was not the case. So every single bank had their own custom way to communicate between different pieces of the banking software. So now they are all trying to standardize around APIs. And the main thing of all of this, of course, is how can we accelerate? What's the way that we can get faster to market? Because otherwise, in the future, we will be bleeding customers. So you can pass the next slide, please. So, and all of this is said with a lot of legacy, right? So most of the banks, they have aging infrastructure. And by aging infrastructure, I mean that some of the core parts of the banking infrastructure, they still run on mainframes, they still run on software that has not been changed for at least 20 years. And that is not I would say, that is not the banks themselves, that is just the standard of the industry, was all around the software. So there was no real need to move forward or create anything new, because then all that risk would fall onto you. And this means also that some of the core software is very difficult to maintain. There's, I would say, a lot of consultants right now writing COBOL and understanding all software of the banking industry that are very sought for, and they are very difficult to get hold of as well. So it's becoming more and more problematic. And we need also to increase that API usage, as we said. So there's banks that are starting to approach this with an API first strategy. And that means that any piece of software, any new component of the banking software needs to be API first. And then, of course, the migration to the cloud, which is challenging for everyone, but especially for risk-averse organizations as banks and insurance companies. They normally do not have cloud expertise because they didn't need that. They didn't hire for that. So now they find themselves in a position where they need to compete for that engineering talent with the likes of Facebook and Google and all the big companies that are several years ahead in cloud expertise and are more attractive to this talent. And then all the risk and governance process, I said it needs to be faster, because right now it's very heavy, it's very slow, it goes through a lot of different hands manually. So we need to find ways to define new frameworks for risk and governance that are agreed across the organization and are compliant with the regulator, which is the FCA. So if you can pass the next slide, please. And the FCA, for people that do not know it, is the Financial Conduct Authority, is the regulator for all the banking industry in the UK. And it's the peer of the European Conduct Authority. So it's the finance regulator is strictly for the UK and the UK banking industry. But the FCA has defined some rules on how banks can actually go forward. Next slide, please. So, and one of those are the cloud framework as estimated by the FCA. The cloud framework defined by the FCA says that banks are now encouraged to move to the cloud, where in the past they were prohibited from going to the cloud because it was considered too risky. Now they are encouraged to go to the cloud. Is the way to go ahead. It's the future. But at the same time, there's three things that any bank that goes to the cloud needs to do. The first one is that they need to show that they are reliant on more than one cloud provider, because the FCA doesn't want any bank to just be one cloud provider, just in case that cloud provider would go out of business or can have an outage. The banking function needs to keep running and needs to keep working. So any bank needs to show proof that they are running in more than one cloud provider and they're doing that in an efficient way. They also need to show that they keep following all the controls and governance framework that the FCA has defined. And this applies to everything, not only to cloud. So they need to adapt that to cloud. And the way to adapt that to cloud is what the FCA have provided, that it's called the Cloud Controls Framework. And the Cloud Controls Framework is a guideline from the FCA. It's a document that I personally have gone through. It's more than 80 pages, so it's quite dense, but it gives you every single detail of all the controls for security, risk, and governance that you need to have in order to go to the cloud. Next slide, please. And then on top of that, there's another challenge. The FCA is pushing all banks to convert into open banking. And open banking is an international standard. It's an international standard that has been agreed in broad terms by the European regulator, the American regulator, and the UK regulator. So in that sense, the open banking standard is as close as you can get to secure digital banking across different parts of the world. So you can pass the next slide, please. In the case of open banking in the UK, it's an organization that has been created by the FCA. So it's a private organization, but this function is to ensure that all the banks are compliant with the open banking protocols, and it provides all the framework, documentation, and guidelines of everything that is involved around open banking. And it's all in line with Her Majesty's Treasury, so the UK government push for these open banking standards to go through. And the objective of this is that the UK wants to be one of the first, if not the first country in the world, to be able to fully establish all the open banking standards across its financial network and insurance networks in order to be able to interoperate with the rest of the world in a secure digital way. So if you can pass the next slide. So these are the main parts of the open banking standard. There's a series of rules that define the data standard. So what is the data sovereignty? So where the data needs to reside, what are the controls for data, what is the encryption that needs to apply to data. It also establishes all the API standards for interbanking communication. Make sure that all the banks need to follow this API standard, and that all the other banks then will expect to be able to communicate across using those standards, and also the different security standards. So all of these standards, as I said, they are part also of the FCA cloud controls framework. And then on top of that, we have all the governance model that is required to be able to run the open banking standard that adds on top of the risk and governance model of the bank. So you can pass the next one, please. So open banking, where we are right now with open banking. So in the last years, the FCA and the open banking organization have signed up the seven biggest banks in the UK to start creating this open banking network between them. I worked for a couple of years in infrastructure in one of these banks, and I was very closely following the open banking, all the open banking implementation, because that was part of my responsibility. So the first wave of that implementation was implementing all the open data APIs. And what this will do is that now, if you are doing banking in any of the big banks in the UK, and you're doing mobile banking or banking or remote banking through the web, you will be able to not only connect and see all the data that you have in your bank, but if you are a customer of any other products of any other bank, so for example, you may have your bank account in one bank, but you may have your mortgage in a different bank. So now with the open banking standard implemented, you are able to see all your financial position across all the different organizations in one single portal. And that all the different online banking solutions will actually allow you to do that both through mobile and through web. Then the next part of the open banking standard that was implemented, it's what we call COP, the confirmation of payee, which is a way to agree and authenticate payments between banks. So this only applies to the confirmation that the payee is a valid member of the bank, that the bank account is legit, and that the data that was supplied in order to do that payment is also the right data and is not something that somebody else has created. And now, for the last 6 months, all these 7 banks have started working on what we call the digital secure payments. And the digital secure payments would be, in a way, PayPal on steroids. So you can use that to be able to pay directly from your bank account with the standard across all kinds of different shops based in the UK. So if you can pass the next slide, please. So where does this put us, right? Because as a financial organization, whether you are an insurance company, whether you are a bank or any other kind of financial institution, you have all these risks when you're moving to the cloud, and all of them, most of them are around governance, risk, and security. And the main ones, as I said, how do you keep moving at speed while maintaining the risk appetite of the organization? Through governance, how can you get all the governance framework in a way that is a lot faster to go through governance, because otherwise, as I said, you are losing speed of delivery to market. Then also, how do you automate all the data sovereignty? How do you make sure that the data is stored the way that it should, that it's secured in a proper way? And how can you put all the policies and rules in order to guarantee that you're doing all the right things for data keeping? And on also, how do you adopt your security processes for the modern cloud world? Because a lot of banks, what they normally did for security was a very painful manual process where you would have a security officer with a lot of Excel and a lot of Word documentation, documenting all the processes and checking that everything was inside those security processes. But nowadays, going to Agile, going to cloud, this is not possible to run it like this anymore because it's way too slow. So banks need to adapt their ways, and they need to start incorporating things as policy as code, or as all the ways to automate this security. And once that's said, handing back over to Pedro so he can talk a bit deeper into our solution for these challenges.
Thank you, Marc. So yeah, we're gonna delve into Vault and those aspects, those issues that the highly regulated companies and the financial sector in terms of security, data sovereignty, governance, and risk face. So Vault is one of our tools, and we're going to provide a brief introduction to what is Vault. I promise to be brief in this first slide, but Vault is a complex tool, but it's a simple tool in terms of principles. So let's go back a few years and remember how traditional high trust model works. So a client might request access to a backend system to get some data. And in order to do that, that client, that is typically a human or an application, is going to use some set of credentials, typically static credentials. And humans, applications, we are terrible keeping secrets. Those credentials will eventually get leaked either by a human or by the application. So it's a matter of time that those set of credentials, those certificates will be posted on GitHub, will be in some reports of security, in some compliance report, or in some solution of any kind. So it is critical to have a low trust environment where Vault can insert itself in the middle, and you can see it in the diagram, and it's going to be an identity broker. So Vault is going to leverage whatever you trust, and that can be Azure, can be AWS, can be an LDAP. So whatever is your source of trust, your source of identity, Vault can leverage that. So you can define policies that are going to be enforced in runtime. Then you might get access to the secret. And that secret, that asset can be managed, can be rotated. And that's the magic of Vault. Vault is going to be an identity broker that is going to insert itself in the middle, and is going to be brokering the access between the applications and the different parts based on identity with the assets, the secrets, and is going to be able to rotate. And there are a few use cases. And let's go back to this slide that we were seeing at the beginning of presentation. And the security tier, the security layer, is moving from a high trust IP-based environment to something that we call low trust or zero trust identity based. So that identity is something that we're gonna be paying attention in order to define the workflows, because let's remember that it's about the workflow and not the particular technology that you use to leverage identity or you use to keep your secrets. So Vault has a few use cases or set of use cases. One of them is secret management. The other one is encryption, and typically encryption as a service. And the other one is identity-based access. We're gonna spend really little time on this slide because we are gonna delve into these use cases in a bit. And Marc was talking about some of the principles and some of the guidelines of open banking and some of the challenges in the industry. And Vault really addresses those challenges with the principles in mind. So Vault is an API first product and is an API driven product. So you can use the API to codify, to automate the access to the secrets. And the entire lifecycle of secret management can be automated as opposed to manual ticketing and some other solutions. So API driven workflows are critical in order to achieve some of the objectives that Marc was mentioning before. And richer automation can run orders of magnitude faster and will avoid all kinds of errors, because automation is key in order to achieve that. And this is one of the Vault principle, but also we have the security, the secure with any identity. So you can leverage Kubernetes or Okta or Ali Cloud or whatever comes in the future. So in 5-10 years, you have a new source of identity or an old source of identity that you want to integrate. Vault is extensible in that regard. So you can secure your workloads with any identity. Whatever you trust, Vault can leverage that. And another principle is the extension and the integration of Vault. So Vault can be integrated with many technologies. So you can find secret engines with all kind of databases. You can find secret engines for message queues. You can find secret engines for cloud provider secrets. So any technology can be integrated into Vault. Vault is an open source product that has an enterprise version for the business challenges that enterprise usage brings, but is extensible and very able to integrate into different technologies. And having said those bits, we're going to spend a bit of time in this slide. So this slide depicts a high-level overview of the architecture of Vault. So Vault, we were mentioning before, that is an API-first product, and all the functionality is available through the API. But that doesn't mean, obviously, that we need to be developers dealing with the API all the time, because there's a logical wrapper around that API in the form of a web user interface. So if you need that ease of a graphical user interface, in this case a web user interface, you also have it. And in the same way, there's a CLI way to interact with Vault, and the two of them are logical wrappers around the API. So all the functionality is accessed via the API. So once you reach the API and you get the functionality, then there is an identity-based system. So we are not talking here about IP addresses. We are talking about leveraging identity and an identity provider that can be, you have a set of technology over there. So it can be a DWT token, can be OpenID Connect technology, can be a GitHub identity, can be different cloud providers, or even the traditional LDAP. So the identity can be leveraged automatically. And then you define the mapping of different identities and different resources, and that's typically policies. So the policy and the governance component, the policy and governance tier, will dictate which secrets we can get and under what conditions can those secrets be accessed. So there's something that we call Sentinel. That is the policy as code technology that is present in all the enterprise products. And Sentinel is going to help us to define under what conditions those secrets can be accessed. So if we want to set business rules around, the time of the day, or the time, the week in the day in the week that certain secrets can be accessed, we can do that with Sentinel. So we can put in place business rules to access our secrets. Under that policy and governance component, we have the audit component. And the audit is critical. Every request and response to Vault and from Vault is audited and is logged. And this is critical because if the audit engine is not working, Vault will basically stop working, because the auditing, the capability of registering every single interaction is critical for the business. So once we get, the API access sorted out, the identity leverage, the policy in place, and the requests are logged, then we get to the fun part. We get to the different types of secrets, the different blocks. So we have what we call static secrets that can be version that are typically credentials or certificates, and we have dynamic secrets, and those dynamic secrets are basically a moving target for an attacker. So we were mentioning before how application will eventually dump into logs set of credentials, passwords, users, etc., and how users they can even upload those secrets into tools like GitLab and GitHub. So the dynamic secrets are basically moving targets for an attacker. So you can define the lifetime of a certificate. So you can create certificates that are valid for 1 day, for a week, for 10 minutes if you want to. You can generate AWS identities that are valid for 5 minutes, for a week, for a month, and the list goes on and on with the different type of secrets. So you can have dynamically generated set of credentials for accessing your databases, for accessing your clouds, for accessing your message queues. And also there's a third block that is crypto as a service, that is encryption as a service. Because if managing secrets is complicated, managing the different types of algorithms and the different type of subtleties in cryptography is way more complicated. There are many aspects to consider, and many times companies find themselves with weak algorithms and poorly implemented cryptographical solutions. So Vault offers the possibility to consume cryptography as a service. So you can have a set of algorithms and set of keys that you can control, and developers and users can just consume cryptography as a service. They will just tell Vault to encrypt or decrypt information, and that will work. So those are basically the three main blocks of three main types of secrets. And we were mentioning before the use cases. So there are clearly one big block of the main use case, that is the secret management, where Vault is going to be the identity broker. It's going to be the central place to define policies and business rules that will allow that centrality in the control. Then there's another set of use cases, that is data encryption. That is what we were just mentioning, basically the encryption as a service and the ability to encrypt data at rest and in transit in your organization. And then we can find some more advanced data protection use cases. So there are things like data transformation, data masking, things like augmented entropy. If you need to leverage some strong source of randomness for whatever reason, you can do that with Vault and things like an HSM. You can integrate even KMIP servers and KMIP protocols with Vault. And those things, those use cases, allow us to achieve that single control plane for cloud security. So in that way, you can have a highly available single control plane for secret automation. That single control plane will be able to define business rules, as we were saying before, with Sentinel and with policy as code. And that single control plane can be integrated with existing and even future technologies. And in order to recap, we're gonna give some figures about Vault. Vault is serving more than 2 trillion transactions globally, and is a very popular product. So it's quickly becoming the de facto standard in security automation. And now that we know a bit more about Vault and the challenges in the security industry, if you want to know more yourself, you can get to the learning portal, learn.hashicorp.com, and you can find plenty of resources for learning a bit more about Vault and the rest of the tools. And with that, I would like to introduce David Duke and start a Q&A session. So David, you have plenty of expertise in the industry, but if you want to introduce yourself, please go ahead.
Hi. Yeah, I've been using HashiCorp Vault now for around about 3 years in the financial industry, and yeah, we've used a number of different use cases. So yeah, I'm happy to talk about that.
All right, and what has your experience been like with HashiCorp Vault?
As I say, I've been using it for around about 3 years, and when I originally took it up, there wasn't that very now useful Learn website that you've got, so it was a bit more difficult on the uptake, I felt, for the team. But once we understood the principles that you were kind of talking about, it became such a powerful tool for us. It really got integrated across the board. So in general, it's been really positive.
Nice. Okay. And why did you decide to go with Vault Enterprise over open source?
The main reason I felt was because of the support that was offered, the expertise that was offered by the Vault team behind the scenes, and there was some of the features as well which were super useful. Again, going back 3 years, some of them have since been open sourced, things like the UI and CMake, the auto unseal. But obviously there is still a number of features in there for the enterprise, things like DR, replication, things like that as well.
Okay, and what use cases are you using, or were you using in the past Vault for?
Yeah, so we used a lot of use cases for Vault, to be honest with you. I think pretty much everyone will start with the KV side of things just to get used to it and understand, again, the key principles that you mentioned. But I guess one of the main ones that I'd like to talk about is the GCP secrets one. We were using Terraform quite extensively. to provision our infrastructure. And one of the problems with that, if you don't have a solution like this, is you'll end up having these very high privileged accounts, JSON keys, which end up lying around. And how do you manage that? If somebody leaves, how do you manage that? How do you make sure it doesn't get into the wrong hands? These accounts could lie around for weeks, months, years if you don't have a good process in place. So the integration of HashiVault for us was very powerful. We were able to connect our Terraform up, and it was integrated within the pipeline, within our pipelines. And that meant that these very powerful JSON keys, remember, these can create infrastructure, delete infrastructure, that they are very powerful. These JSON keys were then just around for a matter of minutes while Terraform did what it needed to do, and then it was then subsequently revoked by Vault. So something like that. And I don't think that's just applicable to financial industry, but I do think even beyond that is something that's a very, very good use case.
Definitely. And we were talking about open banking and different regulations, and financial industries are really affected by regulations. There are many compliance aspects that you need to consider. So did regulation and compliance drive your decision for using Vault?
Definitely would have been part of that decision. I know that the company that I work for were FCA approved and those type of aspects. But I think the full scale of Vault that it had to include all of the features that Vault offers as well. There's no point in just in choosing a product that doesn't have the amount of different secret engines and auth engines and stuff like that. I think Vault just became a very good choice for us in that regard as well, to be able to be a kind of a one-stop shop for secret management.
All right. And talking now a bit more about the future, and what do you see HashiCorp as part of your digital transformation going forward in the future? Yeah,
HashiCorp Vault, as I mentioned, was kind of ingrained into our pipelines as a whole, just for us to provision new infrastructure and all these other aspects as well. But yeah, HashiCorp was kind of right in the core of all of this, to be honest with you.
Okay. Really interesting, Dave. Okay, so I think we should probably now go back to Connor, and let's see if the audience have some interesting questions for Marc, for you and myself. So let's see the audience.
Absolutely. Thank you, Pedro. Thank you, David. So we've had a couple of questions come through. Just starting from the top is, I'll say, a question for Pedro. How is Vault deployed, and is it available as a managed service?
Yeah, that's a very good question. So Vault is available as a managed version. So we did announce ACP Vault the 7th of April, if I remember correctly. So you can have HashiCorp Vault and all the potential to manage your secrets in a managed way. So HCP Vault is a reality. And if you don't want to operate Vault as a managed service, you can do it yourself. So the, let's say, more classic or traditional way to implement Vault would be something like on-prem. And when I say on-prem, could be your data center or your own region in a cloud provider. So we have different reference architectures to implement Vault. So if you are implementing Vault in your data center with VMware, you have a reference architecture, and that comes in a fashion of highly available clusters and recommendations for the installation of different features like DR, like disaster recovery replicas or performance recovery replicas. So depending on the way that you want to implement Vault, you have a reference architecture defined by HashiCorp with the best practices that you can leverage.
Fantastic. Thank you, Pedro. And another question for you as well. Which is a good practice to keep users' identity in LDAP or database as per your experience?
Well, and in previous lives, I was an IT auditor, and I think Dave was mentioning that many times we see different people leaving organizations or moving through organizations, and they tend to accumulate privileges and credentials, or they just are active and they are no longer part of the company. So a good practice in terms of leveraging Active Directory and databases and permissions is to actively monitor that. And many times it's very complicated to do that thing, because those applications are basically all over the organization. And with Vault, the great thing about Vault is that you have a control plane that you can centrally manage, and you can see what are the users, what are the accounts that are being recurrently used, and the ones that are no longer used. So you can audit those interactions, and then define and trim the access to the recommended practices about the least privilege access to secrets.
Yeah, I would like to add to that as well, that it's not only important to have a tight control on the privileges and accesses, but also one thing that the whole banking industry learned from the hack that happened a couple of years ago to Capital One, which is one of the big banks in the United States, is that it's also very important to make sure that you have a very tight data control framework, in the sense that, for example, Capital One was doing exactly all the right things, but the attacker got hold of the database credentials, and as soon as they did, then they were capable of accessing the database and being able to access all the data in clear text, even if the data was encrypted on disk and was encrypted on transit. So that is something that a lot of organizations tend to overlook. Not anymore, of course, because we have learned the lessons of that attack, but it's very important as well to have a very tight control, not only in the data access, but also on how do you keep the data and how do you encrypt the data.
Fantastic. Thanks, Marc. And just a final question for you, actually. Where does Vault store its data, and how is it protected?
Is a question to Marc, to myself?
To Marc, that one.
All right.
So Vault has different backends for data. So it has normally it used to be console mainly, where it stored the data, and all the data was stored in an encrypted way with internal certificates from Vault. But now there's a new engine called Raft, which is exactly the same engine that is used on the console, that is implemented directly in Vault. Which is quite convenient. The thing that I really like personally about Vault, and it's something that in my previous life as a manager for a big cloud platform for a bank, used a lot of Vault, is all the advanced data protection features that it has, and especially all around the database data protection. So any data that we had that was, as we call, user identifiable data, we would encrypt that with an internal certificate from Vault that would be rotated on a monthly basis. And that added a layer of security that we made us actually very happy and comfortable with the whole security model in the cloud. And even the FCA started looking at these, at what we did, and started to add that into their own framework.
Okay, thanks, Marc. And I said that was the final question, but we've got one that's just come through that I think would be great for you as well. And that is, do you have any use cases regarding open banking and securing transactions?
So the regulations for open banking are fairly tight and well-defined in that sense. The main thing is that the open banking framework will define how do you interact with other banks and how do you encrypt and authenticate the data, but it will not define how do you store that data. That falls onto the FCA guidelines for risk governance and data sovereignty. In that sense, I said the banks can interact with one another, but they have to do that in a standard API way that is secured and is authenticated by signed certificates that are recognized. But the rest, so what's behind that API communication, is normally governed by the bank itself.
Got it. Just to follow up to that is where HCV is used.
So HCV, actually, I would not have to look what HCB means in this context. Let me quickly look at that. Okay. Oh, HashiCorp Vault. Sorry. Yeah, I've never heard it call it like that. Sorry.
Yeah,
So
we did HCP Vault, but it's
yeah. So HashiCorp Vault, in this case, related to open banking, we used it in the bank that I said I was in charge of the platform. We used it to be able to generate all the certificates that we use for the open banking transactions. We went all the way to generate certificates for the different components on demand, so we would be able to spin up new methods and spin up new parts of that open banking APIs, and all of that would be done in automated fashion. So Vault was responsible for all the certificate management and certificate creation and certificate expiration of that, because we wanted to make sure that all the open banking data was assigned to certificates, that the CA of the certificate was known by the rest of the banks, but at the same time, we wanted to rotate the certificates enough to avoid any kind of certificate expiration or even certificate steal in the case that somebody actually tried to penetrate our platform. So we would be rotating all these certificates on a monthly basis.
Got it. All right. Thank you, Mark. So with that, we'll conclude today's webinar. Thank you to Mark, Pedro, and first and foremost to David as well for joining us today. As Pedro and David mentioned earlier, if you do want to learn more about HashiCorp Vault, then I really encourage you to check out our Learn site. And you can find that at learn.hashicorp.com/vault. Also, just a reminder that today's webinar was recorded and we'll share that with you via email in the next 48 hours. So with that, I hope you enjoyed today's session and thank you so much for joining us. Thanks, everyone.